Hey, welcome back, students. In this video, I'm going to go ahead and address how to identify and balance synthesis reactions. And I'm going to go ahead and provide you with two examples for this video just so you have some practice, but keep in mind that there are many of these types of examples provided in your book beginning on page 256. So we know that when we look at synthesis reactions, the general formula that we use for that, or that is often used to describe them, is when you have an element A reacting with an element B, and this goes and forms a compound AB. And so the two reactions I'm going to show you, I'm going to go ahead and identify these generic labels AB in them so that you can see where they really are. And we'll begin with one that we've actually used in class, and this is a very simple one, where we took magnesium and we reacted that with oxygen, which is O2, and this went to form a compound that we called MgO, or magnesium oxide. And so if you look at this here carefully, what we've got, and I'm just going to go ahead and identify these here at the top, you have A, you have B. When you add them together, they go and they form AB. And you can see that at the very top here. And so what's going to happen here is magnesium just simply joins with oxygen, forming a new compound, AB. But let's go ahead and balance this, because this is really important that we actually learn how to do. We do begin by first dividing the left and the right. So on this side we've got the left, and on this side we have the right. Now we count the atoms on the left side and make sure that we have the same number of atoms on the right of the same element. So we'll begin with the first one, which is magnesium. So if you look at the left-hand side of the equation, we notice that we've got one magnesium. And we go to the right side and we notice that we've got one magnesium. So at least with our magnesiums, the magnesium count is the same on the left as it is on the right. Then we turn our attention to the oxygens. And notice here that we've got two oxygens. Notice the little subscript 2. This little 2 indicates that we've got two oxygens on this side of the equation. So we look over on the other side of the equation, and we notice that the magnesium oxide only has one oxygen. So what we are needing to do here is we need to add another magnesium oxide. And what that will do is that will bring our total oxygen count to 2. But in doing so, yes, we may have balanced our oxygens because now we have 2, but what we have done now is created a situation where we have two magnesiums on the right. Notice on the left-hand side we've only got one, so we are then required to add another magnesium to the left-hand side. If we do that, what we've got here now is a total count of our magnesiums here of 2. Notice we've got 1 unit, 2 units. So then we're going to have to add a coefficient at the front of this magnesium, indicating that we've got 2 moles of magnesium. If we turn our attention to oxygen, we notice we've got 1 unit there, or rather 1 mole of oxygen. And so let me change that in to this color. We've got 1 mole there. And if we look at the magnesium oxides on the right-hand side, we've got 2 units there, indicating that we've got 2 moles. So if this were a problem that you encountered, say, on a quiz that's multiple choice or an exam that's multiple choice, what you want to do is you want to go ahead and look for the answer that provides you the following coefficient number. Maybe perhaps you've got like an A, a B, a C, and I'm not going to write these out, but let's pretend that our answer for A actually said 2, 1, 2. This would be the right answer because essentially the 2 here is the 2 that we identify there. The 1 here is the 1 identified with oxygen, and the last 2 is identified with the mole number for the magnesium oxide on the right-hand side of the equation. So this is the first example of the 2 that I was going to provide you. Let me go ahead and show you another example. Okay, so we'll begin again. I just cleaned the screen for us, but again, let me just write what we know. We know that A is going to react with B, and that's going to form compound AB. All right, so here we go. The second equation that I want to show you is the following. Let's say that we have iron, and so iron is going to be Fe, and Fe reacts with oxygen to form FeO. Now, I could make this a little bit more complicated and kind of try to figure out what is the subscript for the FeO on the right-hand side. But what I'll do, just to make this a little easier for us, I'm just going to tell you that it forms a compound where you have 2 atoms of Fe and 3 atoms of oxygen for this compound. Okay? And so our job now is to identify how we go about balancing this equation. And we first begin by writing the line in the middle, left and right, and we do this at the arrow that indicates that that is the middle point, or the line that divides the left and the right sides. And then I begin by looking at my iron on the left-hand side. Notice I only have one iron, and we can see that here. And on the right-hand side, notice I have two. So I would need to add another iron to my left-hand side, which I'm going to do now. Now I've got two irons on the left, two irons on the right. So then I can move to the next atom on the left, which is the oxygen. And I've got two oxygen atoms on the left. But on the right, I've got three. Now, this is a situation where you notice that this subscript here is odd. The first thing that I would be inclined to do is to just go ahead and add another compound of Fe2O3. And if I do that, notice that now my total oxygens is even, because 3 from the first one and 3 from the second one gives me a total of 6 oxygens. Now, once I've done that, I've increased my iron count to a total of 4 on the right, which means I need to come back over here to the left-hand side and I need to add 2 more. And so now I've got a total of 4 irons on the left, 4 irons on the right, and now all that's left to do is to balance out my oxygens. So I begin with the oxygens on the right. I've got 6 there, and you can see that here, 3 and 3. That'll give me a total of 6. And I've only got 2 on the left-hand side. So I'm going to have to add one more molecule. That'll give me 2. And then I'm going to have to add another one here. And that'll give me a total of 6. So if you can count them, there's 2, 4, and 6. So my oxygens are balanced now. All that's left for me to do is to count the units that I've got. So notice here I've got 1, 2, 3, 4. So that I need to put a coefficient number of 4 there. And if I go over here to the oxygens on the left-hand side, I've got 1, 2, 3. So the coefficient number there is 3. And on the left-hand side, I've got 2 units of Fe2O3. That's 2 of those, so my coefficient count here for that one will be 2. So here are the coefficients, and what you want to do is look for the answer that provides you the following coefficient count: 4, 3, and 2. All right, so those are the 2 examples. I know we went a little bit long on 7 minutes, but hopefully that'll be helpful for you. Check out the next video, and hopefully that will help for you to do your homework.